Testing. Alright, chapter 2, part 2, carrier reinsertion. The need for the frequency above with your single side band with the operator for the extremely critical with the even with the single small deviation for the correct vote. The local oscillator with the frequency call with the intermediate frequency produced with the mixer with the display for the correct value, the automatic amplitude modulate for the reception and not too damage single carrier with the side bands are all perfect will display and an equal amount therefore relative to the position of the carrier with the side band but with the retain with the however the single side band with the reception with the no carrier only one side of the amplifier for the income single with the carrier reinsert for the oscillator frequency intermediate frequency that would have the result of the carrier to being present with, for example, assuming the transmit for the carrier the frequency of 3 MHz of the radiating the upper sitting side band signal, assuming the intelligent consider the 100 kilohertz tone of the transmitted side band frequency with the 3001 kilohertz for the receiver that have the 500 kilohertz intermediate frequency, the correct local oscillator frequency be 3500 kilohertz. The output mixer over the intermediate frequency stay with a difference for the frequency of 199 kilohertz. Therefore, the carrier area insertion oscillator frequency would be 500 kilohertz with a maintain with the frequency relationship with the carrier to sideband 1 kilohertz. Recall that 1 kilohertz modulating with the local oscillator frequency should be driven to 500.5 kilohertz for the intermediate frequency output for the mixture between 499.5 kilohertz for the carrier reinsertion oscillator. However, they will be operating with the 500 kilohertz with the result of the incorrect audio output with 500 hertz rather than the correct original 100 kilohertz tone. Suppose the intelligence transmit with the complex signal such as speech would then find with single unentangled because of the displacement and side effect of the count of the local oscillator deviation. Local oscillator with the carrier reinsertion oscillator must be extremely stable. Receiver to control circuit with the section of the detail of the circuit with the control receiver the function will explain how some of the basic manual and automatic receiver the control functions work. The manual gain control with the you've learned previously with the high sensitivity one with the desirable character with the issue with the good receiver with some case with the high sensitivity made undesirable. For example, let some signal receiver from the nearby station from the strongly enough for the overload the radio frequency section with the video receiver. They may couple the audio output to become distorted with one with the completely left intelligently overcome the problem. Couple the use the manual gain control of the radio frequency section. By using the main gain control, you can adjust the receiver the maximum sensitivity amplify the weak input between receiver the strong input signals. The radio frequency gain may be reduced to prevent overloading the typical main gain control for the receiver that is illustrated in figure 213. Let's go for the basic circuitry. The capacitor 1 is emitter bypass capacitor resistor 1 resistor 2 develop the emitter base for the amplifier capacitor 2 provide the DC isolation between the tank and the base for the transistor 1 the should recover the circuit with the Neets module 7 the introduction solid state device power supply modulate introduction amplifier gain may be varied with the changing of the bias parameter with the resistor 2 with the radio frequency gain control with nothing more with the manual base adjustment with the wiper on with the resistor 2 set with the point being minimum forward bias supply with the transistor to cover the amplifier to operate close to the cutoff with the reduce the gain with which move with the control of the toward point with the A with the opposite with the curve with the resistor 1 limit with the maximum reduction and transistor 1 with the resistor 2 short circuit they may run with the alternating base method with the transistor operating with the near saturation. In the case of the large change of the gain will again function as the bias. Main volume control. The figure 214 shows the circuit with the common method of controlling volume with the set through hydrogen receiver with the capacitor 1 resistor 1 with the form of the input signal with the coupling circuit also mean with the controlling level they imply with the audio amplifier resistor 1 resistor 2 resistor the developed forward bias setting and operating point transistor amplifier resistor 4 with the collector load resistor the transistor 1 with the capacitor 3 output signal with a couple of capacitor with the denominator 1 with the resistor 1 with shown with the circuit shown with the input impedance with the save remain fairly constant with the signal proceeding the belt across resistor 1 by adjusting resistor 1 you can change the input level of the transistor 1 removing varying output amplitude. So this shows the typical manual main gain and volume control automatic gain and volume control auto with the variation receiver they often result with the variation input signal strength with the change with the input signal strength with the all curve with the change with the station when extreme with the fading because of the change of the automatic atmospheric condition the function automatic gain control also referred to the automatic volume control limited unwanted variation output with the receiver the cover with the variation strength with the receiver the single input of the receiver with the automatic gain control with the would require the continuous manual readjustment to compensate with the received signal change could maintain a continuous constant output level. The signal from the station is operating with the staying with the power level that will may not reach with the receiver. They intend with the same power with the peak over the difference with the transmission difference with the carrier, the frequency of the atmospheric condition, the obstruction between the transmitter with the receiver antennas. You might draw the conclusion that the automatic gain control of the network is not necessarily the receiver operating with a single station. However, it is not true with the atmospheric condition. Make up with a single strength of air with the fade in and fade out with the antenna may receive the component for the signal, which have traveled along different paths. For example, the one component may travel directly from the antenna to another may have the been reflect with the distant option. Two signals sometimes to be in favor of the other type of the be out of favor the tending of the reinforced to cancel each other out. The resulting variation signal string and the receiver antenna the variation signal strength they often refer to as the fading. The effect of the fading and the output signal variable to the radio frequency stated the base of the best demonstrate with the following example. The radio frequency amplifier connected with the receiver the antenna voltage of the gain of the 100 volt antenna receiver the input signal of the 10 microvolt the output voltage is computed 100 times 10 microvolts is 1000 microvolts microvolts 1 millivolt. When the output voltage is equal to 1 millivolt, is fading to be avoided, but the output voltage must remain at 1 millivolt. However, the reflected signal will receive with approximately 1/2 the strength of the 5 microvolts originally in the phase of the original signal. The total input signal of the receiving antenna increase with the 15 microvolt for the maintain the decrease with the 1 millivolt for the output signal. You must somehow reduce the gain of the radio frequency amplifier input with the 15 microvolt. The desired output of 1 millivolt with the gain amplifier will be reduced 1,000 times 10 to the negative 6 volts over 15 times 10 to the negative 6 volts, 66.7. 10 microvolts original signal with the 5 microvolt will reflect the signal out phase with each of the signal strength with the receiving the antenna will decrease with the 5 microvolt will maintain with the original 1000 microvolt output signal voltage gain with the amplifier must increase with the flowers 1000 microvolts times 10 to the negative 6 volts of the 5 10 to the negative 6 volts to 200 the variation of the amplifier simplifier similar example the necessary with the you have the gain of the compensator with the input signal strength with the variation of the required amplifier gearing variation can accomplish automatic with the adding the automatic gain control signal with the receiver. Let's take a look with the method of the circuit used produce the automatic gain control manner of which the automatic gain control automatic volume control receivers gain. Circuitry. Figure 215 block diagram is representing the automatic gain control feedback with the proceeding state of the detector circuit with the DC component with the output with the directly proportional to the average amplitude of the modulator care for the automatic gain control circuit. You have the DC component filtering detector output with the remove the audio intermediate frequency component with applying with the portion of the DC component with the preceding stage of the automatic gain control volume voltage control with the amplification and of all any of the stages received with the detector stage solid state with the receiver that may either be powered with negative voltage for the automatic gain control of the type of the transistor you have the element of the control voltage applied with the to determine the type of we will have. The antenna radio frequency mixer with the intermediate frequency of the detector, automatic gain control going to the intermediate mixer and the radio frequency and automatic detector audio frequency amplifier. Circuit shown figure 216 pipe with the place pipe. The automatic gain control volts of the transformer 1 with the diode 1 and capacitor 1 resistor 1 combiner with the shear with the diode detector with the automatic gain control network remaining with the resistor 2 and capacitor throwing the normal detector operation 5 with the potential showing the input with the diode 1 conduct with the conduction of the diode will cover over the current change with the change charging current with the dash line of the flow through the automatic gain control capacitor 2 and the automatic gain control resistor 2. Charging of the current with the develop of the voltage with the cross capacitor 2, the potential across the transformer 1, reverse the diode with the reverse bias of the will conduct with which half of the charging the current cause of the capacitor 2 to be begins to discharge the discharge path of the capacitor charge over the air over the discharge of the path time of the constant with the capacitor 2 resistor 1 resistor 2 over them be long with the period of 1 over the frequency of the low of the auto frequency present with the output of the detector because of the longer time with the constant with the capacitor 2 will not discharge much between the peak of the modulating signal with the voltage across the capacitor will essentially at a DC voltage with the voltage proportional to the average signal amplitude. Now the single strength of the vary with the capacitor will increase the decrease in this charge. Depending on whether the signal increase or the decrease of the signal charge of the automatic gain control capacitor respond with only with the changes over the average signal level, the instantaneous variation of signal will not affect the automatic gain control voltage. Here the diode detector simple automatic gain control, the adjustable capacitor transformer 1, diode 1, capacitor 1, resistor 2, and capacitor 2, resistor 1 to audio amps, automatic gain control voltage preceding stages. You should remember that depending on the transistor type of the receiver that may require the either the power or negative the automatic gain control, the negative automatic gain control voltage can be easily obtained by the reversing diode 1 on to the value of the resistor 2 and capacitor 2 have been selected with the voltage desired action. The component is fixed with a circuit operated with the automatic without further adjustment. If the average amplitude of the signal increase the charge of the capacitor 2 will also increase the signal amplitude decrease the AC so charge the discharge of the so does the charge of capacitor 2. Automatic gain control receiver the provide the control degenerated feedback adjusting the operating with the point of the amplifier control of the gain with the no signal with condition by for the radio frequency intermediate frequency amplifiers the standard mean with the self bias for the applied signal with the automatic gain control voltage developed in conjunction with the normal biasing method to develop the operating bias for the amplifiers. Transistor amplifier gains. You have seen how the DC voltage of the time of the output of the automatic gain control with the network is proportional will reflect with the average variation of the average signal level that now we all have to use do this automatic gain control voltage of the control of the amplification one or more with the preceding amplifier. Figure 217 illustrates the common demand of the amplifier with the automatic gain control amplified applied to the base element with the chain with the automatic gain control voltage, chain with the operating point with the transistor DC emitter with the current with the circuit with the resistor 1 and resistor 4 with the voltage divider, supplements no signal forward bias on the base of the signal with the positive negative of the transistor, U with the base of the negative potential automatic gain control voltage detector positive the respect with the ground with the fed with the base with the dropping resistor 2. We'll find whether the DC output of the detector input increase the because of the increase of the average signal level the automatic gain control voltage will become more positive. The increase of the positive potential is applied with the base of the transistor 1 decrease of the forward bias of the transistor 1 decrease of the gain of the amplifier. Automatic gain control applications work with the control degenerate feedback of the negative power of the negative transistor. The same configuration would require the automatic gain control voltage to possess the negative potential Show the automatic gain control voltage input and the resistor 1, resistor 2, resistor 3, and capacitor 1 on the transmitter, resistor 4, capacitor 2, and the transformer 1 output with the voltage current collector, the forward bias, reverse automatic gain control. When you the automatic gain control, to cover the generation derived from the amplifier, the torque, the cowl, reverse the bias, reverse automatic gain control. Figure 218 show the typical automatic gain control. Normally, you this method, the second method, you the automatic gain control application called forward automatic gain control. In K for the forward automatic gain control, you'll find the amplifiers driven over the saturation region with the character for the curve, sometimes referred to as the energy diagram. Show the transformer, capacitor 1, adjustable capacitor, capacitors 5 and 2, resistor 2, capacitor 3, and resistor 3, capacitor 1, and capacitor 2, transistor, transformer 2, capacitor, adjustable capacitor 6, of the diode 4, capacitor 4, resistor 5, audio frequency output, automatic gain control. Let's look at our example to assume that the automatic gain control is negative under the condition of the transistor 1 of the base for the no signal with the condition operating as well with the output character for the signal applied with the negative automatic gain control with the develop the detector circuit fed by the resistor 1 will increase. The forward bias with the increase of the signal level, the cover, the increase of the automatic gain control, increase of the automatic gain control voltage, increase of the condition for the turn drive of the transistor near the saturation transistor approach with the saturation gain with the corresponding reduces. On the other hand, input signal to the level of the decree with the negative automatic gain control voltage, the decree with the forward bias, then reduce the transistor operated lower portion of the characteristic of the when the gain is higher. Forward automatic gain control provided the better signal handling capability. However, the reverse automatic gain control is simply you with the cover less of the loading with the tune circuit with a smaller variation in input and output capacity. Delayed automatic gain control. The disadvantage of the automatic gain control actuation even with a weak signal to overcome the U with the delayed automatic gain control. Let's look at the typical delayed automatic gain control circuitry figure in 219. So the type of system developed with no automatic gain control feedback and the established receiver signal trying to get attained for the signal weak with the non-automatic gain control developed sufficiently strong that a single delayed automatic gain control circuitry operates essentially with the same ordinary automatic gain control. If the intermediate frequency amplifier transistor voltage current collector diode detector audio frequency amplifier audio frequency output automatic gain control diode adjustable delayed grounded. Our circuitry of the two separate diodes, the one with the detector diode, the other the automatic gain control diode. The automatic gain control diode is connected with the primary left of the intermediate frequency of the transformer. The detector diode with the secondary of the probably applied with the cathode with the automatic gain control with the keep of the conducting until the prearranged signal level that has been reached. The adjustable delay control allow the manual control with the automatic gain control double diodes diode bias manual control allow you to select with the signal level with the automatic gain control applied with the most liquid stations R and B. Receive the setting with the B should behave with no automatic gain control until the signal level is high. However, you should set it as low as possible, preventing overloading the last intermediate frequency amplifier stronger signals. Finally, you must have the two diodes obtained with the delayed automatic gain control. If one of the diode where you the automatic gain control would develop with a detector diode, there would be no delayed action. With a single diode where with the bias that provide the delay action is desired with no single word with the path of the audio amplifier until the bias succeeds with the input signal. Or your beat frequency oscillator. Beat frequency oscillator is necessary when you learn to receive the continuous wave. The continuous wave signal will not modulate the audio component. Remember that you must provide within the audio action from the audio frequency amplifier, mixer, local oscillator, intermediate frequency amplifier. Same with the both of the audio, continuous wave amplitude modulation. Continuous wave signal with the reach of the detector signal frequency circle with there's no cycle and slide bands for component with the produce the audio frequency output with the most heterodyne with the beat with a continuous wave signal with the radio frequency signal with the proper frequency of the simpler signal is obtained with the oscillator known with the beat frequency oscillator. Figure 220 with the block diagram super heterodome receiver capable of receiving the modulating continuous wave, the beat frequency oscillator heterodyne with the detector produce the audio frequency with the detector second detector used primarily because of the mixture with the first detector normally with the sort of the automatic gain control radio frequency mixture the local oscillator with the intermediate frequency strip detector, the on and off switch between the beat and frequency oscillator, amplitude modulation, continuous wave, and the detector going audio amp. If the intermediate frequency is 455 kHz, the beat frequency to the 456 kHz with the 454 kHz, the difference frequency 1 kHz is heard with the output. Generally, you will tune with the radio frequency from the front of the panel of the receiver. When you vary with the beat frequency control, varying with the output frequency of the beat frequency, will hear the change with the tone of the output audio signal. Or your squelch, the sensitivity receiver the maximum no signal with the being received the condition curve with the example the receiver being tuned with the between the station for the time background the noise picked up with the antenna with the will hear the noise with the greatly amplified the noise with the highly annoying with the curve that will be covered with the receiver the game with the maximum without a signal where you can often overcome the problem. Using a circuit called the Swisser no silencer, no suppressor, no limiter, with also the noise type of the circuit clip for the keeps the noise spike with the squelch. Actually, the limit is noise figure 221 is a typical circuit type of the circuit with the receiver, the output with no input signal that is being received. The outcome for this blocking either detector, audio amplifier, no signal is present. The theory involved in the process. Show the squeeze diode of the conductor 1 and connect with the output of the first A with the input with the second amplifier with the transistor 1 with the control transistor with the circuit with the anode cathode voltage with the diode 1 is normally base positive with respect to the ground. Alright, there are no inputs over the signal of the resistor 9 jump with the transistor 1 jump with enough of the collector current to reduce the collector with the voltage with the anode voltage with the transistor diode 1 with the value below with the voltage with the cathode diode 1 at the point of the anode voltage goes squelch diode is negative with respect to the cathode conduction with the receiver the audio output the reduce the zero with the result receiver the silent. Base of the transistor 1 connected with the automatic volume control of the line with any time with the signal entry with the receiver the negative AO automatic voltage control with the voltage applied with the base of the transistor 1 reduce the collective current with the increase of the collective current with the voltage with the return increase with the anode voltage with the diode 1 until the anode becomes positive with respect to the cathode, and once with the game with the diode 1 will conduct with the signal will path with the second amplifier audio frequency with the amplifier of the diode 1 is effectively switch control with the automatic audio voltage automatic voltage current voltage automatic voltage control voltage automatic volume control voltage. Audio tune. The tune of the sound repeat video section for the receiver, the dependent of the treble, the fact of the frequency for the balance over the audio amplifier, trim of the degree of the amplification provided the different frequency of the sound spec for the side of the quality of the aim for the loud for the speaker, the determine the response with the various frequency response with the human ear with the final jump with the tonal quality with the variable with the individual. Become the variables for the variable, some of the one low tune control sometime with the name of the receiver, the treble, the define an audio frequency so approximately 3,000 Hz the base of the tone, the below with approximately 300 Hz, several of the tone control can be used going with a mention. Only going to mention actuation method, the method with the degree of the intensity of the one with the tone with the computer with the apparent with the increase of the intensity of the another tone with the example the less one with the tone. Let's look at the tone 400 and 4,000 Hz produce the speaker with the same intensity to reduce the intensity of 4,000 Hz tone with the 400 Hz tone will appear to be louder even though the intensity has not actually changed, but you should see the example, the base of the emphasis of it can be accomplished with the actuating tremble tones. Simplest type of the tone control is illustrated in figure 222 with the fixed capacitor one pair with the primary one, the output transformer. They effectively show the higher frequency of the ground size of the capacitor one determine the low frequency to be effective with the you select from the base position of the tone control the capacitor one connect with the improve of the base to respond with the DM side with the treble tone, but you can often use the circuit to improve the output with a small speaker with the port double response. Treble the capacitor, one base with the transformer, one speaker, and audio output. The continuous variable tone control for the illustrated figure 223, the tone control resistor 1, bypass with the capacitor 1, the variable the RC filter, wiper on the resistor 1, upper base position with the capacitor 1, bypass with the high frequency ground with the better base, respond with the wiper run with the resistor 1 with lower frequency treble position, resistance and resistor 1 as placed in super with the capacitor 1, reduce the shunting effect with the capacitor 1, higher frequency, improve with the treble the response, that gives you the advantage to smooth with the continuous control with all points between the maximum base and the maximum treble response. Show the variable tone control within the RC filter, the capacitor resistor 1, adjustable capacitor resistor with the capacitor treble with a transformer and speaker. Voltage current collector switch type of the variable tone control with the illustrated figure 224, the map of the 3 position switch with the provide with the fixed degree with the tone control the switch 1 base position capacitor with the 1 bypass the high frequency with the provider the base emphasize switch 1 with the normal and the position capacitor 2 act with the bypass with the monitor actuate mount with the high frequency actuation coupled position provided the balance base for the treble to respond with the switch 1 with the treble position capacitor 3 act with the bypass provided the minimum high frequency actuation maximum with treble the emphasis as a rule of thumb you configure the capacity of the capacitor 2 approximately 5 times the value of the capacitor 3 and capacitor 1 approximately 10 times the value of the capacitor 3. For example, the capacitor 3 is 1,000 microfarads. The capacitor 2 would be 5,000 microfarads, and capacitor 1 would be 100 microfarads. This shows the switch for the tone control capacitor 1, 2, 3, base normal, treble switch 1 with the resistor 1, capacitor 4 tuned out circuits output for transformer. Alright, your quartz crystal filters. Quartz crystals, you with the selective filter, intermediate frequency section, communication receiver, the one with the most effective method of achieving the maximum selectivity, especially you for the channel with the crowd with the considerable noise. Both external and internal present, the one possible circuit arrangement is shown figure 225. Look at the theory they involve with the understanding of the circuit that you can see the crystal one leg with the bridge circuit with the secondary with the input with the transformer is bound with the ground with the center tap connection. The crystal acts as a merit receiver with the resonance circuit really allow the signal with the intermediate there is the same with the resonance to path through the crystal output with the coil with the inductor coil 3. The desired signal appear with the center tap of the inductor coil 3 and grounded. Figure 25 show with the crystal you with the intermediate frequency of the super heterodyne circuit with the intermediate frequency resonance security capacitor resistor capacitor adjustable capacitor transformer 1 grounded capacitor 2 adjustable switch and crystal phasing adjustable capacitor 3 induction coil 3 capacitor 5 capacitor 6 grounded automatic voltage volume control, and intermediate frequency amplifier and capacitor resistor tuning circuit. Capacitance of the exhibit the crystal holder plate with the 5 main three capacitor 3 might bypass the unwanted 6 with the better amount of the capacitor. Therefore, the sum of the method to provide with the balance of the with the capacitance coupled with the circuit balancing with applying with the output bases voltage neutralizing undesired signal voltage tap of the inductor coil 3 and permits for the proper input of the matching the imbalance input with the next stage. Alright, automatic frequency control. Automatic frequency control with you the situation where the most accurately control the frequency oscillator with the by some of the external signal with the basic with the type of the circuit with does this type two things for the sense of the difference between the actual oscillator frequency with the desire of the producer the control voltage proportional to do the difference. Also with the control voltage chain with the oscillator with the desired frequency with the automatic frequency with the control circuit you with the control the frequency syncytial oscillator non-syncytial oscillators only syncytial automatic frequency control circuits will be covered here with the automatic frequency control circuit that are with the radio receiver with the frequency modulation frequency modulation transmitter with the frequency synthesizers for maintain frequency stability with the block diagram illustrated AFC automatic frequency control operation receiver. Let's run with the applicable part of the block diagram. Antenna radio frequency amplifier mixer the intermediate frequency amplifier detector audio amplifier. In between the intermediate frequency amplifier and detector goes the discriminator varicap local oscillator mixer and then back the intermediate frequency amplifier. Frequency discriminator with the varicap, the receiver with the varicap, that you with the keep the intermediate frequency stable. You move on to remove the varicap theory in the chapter review varicap theory in chapter 3 with the Neets module 7 the introduction solid state device power supplies. At this point, varicap application produced with the apparent with the reactive will include with the oscillator frequency control circuit with the, for example, let's see assume that the killer intermediate frequency with the 455 kilohertz local oscillator tracking below the incoming station. When local oscillator output with the decrease of the slight with the frequency intermediate frequency will arrive at the cover of the output with the discriminator increase the capacity and reactivity of the varicap which increase the oscillator frequency the desired value. Now let's assume that the local oscillator frequency output with increase the intermediate frequency will then decrease the cover of the discriminator output with the decrease of the capacity and reactance varicap that will cover the oscillator frequency decrease. Figure 227 show another widely used automatic frequency within typically type of the referred to as the balance phase, the technical phase, the discriminative circuit with the figure with the capacitor varying capacity, the two type with the achieve the variable reactance. As you have seen with the block diagram, your automated frequency controllers requires two sections of the frequency detector variable reactance or the detector the output of the DC control voltage proportional amount with the frequency chain with the DC voltages that apply directly to the oscillator phase convert input signal with the discriminated intermediate frequency output fed through the two diodes at 100 degrees out of phase. For the input and input reference to the sawtooth the resistor with the diodes and grounded resistor capacitor controlled the voltage local oscillator. Reference voltage supplied with both the diodes made for the conducting only during the peak of the portion of the input signal with any chip of the oscillator frequency alternating phase relations between the sawtooth the reference voltage incoming signal happens to one diode will conduct with more than the other. The control signal of the system remains unbalanced at all times with any chip of the frequency instantaneously corrected the network between the diode and the oscillator. Essentially, low pass filter prevent the discriminating pulse of the reaching of the oscillator. Your frequency synthesis. The present day of the communication system, the long-term accuracy, 1 part of the million required with the many with the frequency generated local oscillator, the U of the communication equivalent the variable frequency oscillator commonly cannot practically achieve with a high degree of stability. Therefore, the system know the frequency synthesis have developed with the meet with the stringent demand of the stability of the system and U of the circuitry to produce with the signal frequency hedge over their through heterodyne frequency selection property, the signal is not harmonically related to any of the signal using the heterodyne property is also not related with the select with the crystal frequency. This makes the signal unique. Figure 228. The multiple crystal frequency synthesizers produce the desired output frequency by frequencies by several crystal oscillator that each of the oscillator even the 10 or more crystals control the operating frequency to provide a large number of the output frequency combination. Figure 229 practical frequency stabilized with the harmonic subharmonic signal standard of the oscillator combined with the provide the multiple choice output signal. Each of these signals are harmonically related with a subharmonic with the standard oscillator. You will find the primary difficulty encountered with the frequency synthesizers presented in the superior signal with the generated with the common binding mixers with extensive filtering. Extremely careful selection of operating frequencies are required. That even the simplest of the circuits, since spurious frequency problems increase the channel spacing, decrease the range of the operating of the frequency, increases the first crystal oscillator, second crystal oscillator mixer output. Show the frequency divider divided by 10 kilohertz by harmonic generator time 30, 300 kilohertz in the mixer and then band pass filter. Show the standard oscillator go through the frequency divider and the harmonic generator. The harmonic generator produces 2,000 kilohertz out of the 100 kilohertz. The mixer and the band pass filter mixes with the frequency harmonic in the first 30 harmonic generator band pass filter 230 kilohertz. Alright, your audio reproduction device. The proof of the audio reproduction device just allowed the speaker with a headphone with converted with the electro-automatic signal to sound power. The figure 230 show with the diaphragm of the loudspeaker called with the permanent magnet. Speaker with the speaker with the the permanent magnet mounted with the soft iron pole with the voice called with the electromagnetic loudspeaker with the connected to the voice call with the audio signal previously amplified with the terms of the voltage of the power of the amplifier applied with the voice call with the voice call. The mounting center portion of the soft iron pole pieces of the air gaps over the mechanically freely to move the connector with the loudspeaker with the cone moves down. The cone will also move the auto current frequency current flow for the voice of the coil moves back and forth proportional with the apply with the AC current. As the cone diaphragm is attached to the voice call, it also moves the accordance with the signal currents in doing so with the periodic compress with the rarefied with the air produces sound. Show the soft iron pole P with the signal current for the voice cove with the permanent magnet, air gap, and speaker cove. Most speakers above the type of the receiver, the input, the mean with the transformer. Coupling this necessary because of the normal low end pin with the voice cove with the wheel find the standard pin with the value with the type of the speaker. 4, 8, and 16, and 32 ohm. The other impedance value that must be maybe even the same list for the most common. The permanent magnet speaker with the perform responsibly well with the audio range. The limited for the most name of the speaker reproduce low audio frequencies quite well and mid-band frequency fairly well and high frequency quite poorly. Let's see why. The speaker is constructed with one limited number of the terms that may be built with the voice code with give the induction low frequency, the induction of the reactance, voice call relatively low, large audio current flow with the provide strong magnetic field with the round with the voice call with a strong interaction with the field with the permanent magnet, low frequency response with the excellent with the mad frequency, induction of the reaction with the increase of the less current, the flow of the voice call with the produce of the less current magnetic field, less interaction with the mid-band response, but is still acceptable the proper design. Speak with a high audio frequency with the inductive reaction with the quite high with the little current flow with the voice call with the result. Greater reduce the voice call with the field with little with the interaction. Permanent magnetic field with a high frequency with the interwinding capacity. With the voice coil tends to this shunt. Some of the high audio frequency with the further reduce the high frequency response. Because the response most of the power permanent magnets falls over the higher audio frequency. The problem normally overcome with the use of the expansive, the especially designed speaker over the two speaker, the one which is designed to operate the higher audio frequency, the tweeter, and one over the lower frequency, the woofer. As shown in figure 231, the electromagnet may be used to play with the permanent magnet to form an electromagnetic dynamic speaker with it. Well, the sufficient DC power must be available to energize the field electromagnetic operation, otherwise the much same if the permanent magnet type. This type of the speaker is seldom used in the Navy. Show the DC full supply fuel field coil, soft iron voice coil, the speaker cone, and the air gap. Show the figure 232. Show the diagrams help typical headphones with the Navy. The equipment of the device consider the permanent magnet too small with electromagnet. The signal current of the path for the soft iron diaphragm with the converter with the electro effect of the device of the sound power. No signal with the current of the present with the permanent magnet effect. Serve the same power pull with the soft iron diaphragm. The soft with the current flow through the coil mount with the soft iron pole piece to develop the magno motive force over the either adds subtract the field with the permanent magnet diaphragm, thus move it in or out with according to the result in field. Some waves that are reproduced that have the amplitude of the frequency with the mechanical capability to reproduce the similar amplitude of the frequency with the signal currents. The metal diaphragm electromagnetic protective covering the permanent magnet signal input. Alright, as compared to permanent magnet, speak with the standard headphones that are considerably higher in with the headphone electromagnet normally wound with a small wire that provide lower and larger impedance because of the physically small side of the flexibility of the metal diaphragm. The headphones often give the poor response for the lower audio frequency of the voice range. The audio must be standard issue if headphones are adequate. And that was chapter 2, part 2. We had to redo because it didn't record.